Hi there, I'm back with some more exponent rules for you. This is lesson 7.3. It's called multiplying powers with the same base. Today we're going to figure out how to multiply powers with the same base. There is a rule for this, but in order to figure out the rule, I want to take a look through some examples with you, see if you can notice any patterns, and determine what the rule is. So do you see here in all four of these examples, we're multiplying powers that have the same base. See how these have the same base? They both have a big 4. Same base here, x, here's 3, and here's 6. You can multiply powers that have the same base. Let's take a look at what 4 to the second power times 4 to the third power means. You know that a power is a shorthand way of writing a multiplication problem. So if I expand 4 to the second power, I can write it as 4 times 4. And then if I multiply that by 4 to the third power, we know that that's 4 times 4 times 4. Now take a look at what you have here. You have 4 being multiplied 5 times. That's the same thing as 4 to the fifth power. Let's take a look at this one. Again, these two are being multiplied and they have the same base. X to the third power, if I expand it out, it looks like this. X to the fifth power would be x times x times x times x times x. Now take a look at what you have. What if you were to take this and write it as a power? Wouldn't it be x to the, count them up, 8th power? Are you noticing anything? Take a look at the exponents. 4 to the second power times 4 to the third power is 4 to the fifth power. Here we have x to the third power times x to the fifth power, and it is x to the 8th power. Are you noticing how we could do this quicker instead of writing it all out? You're right. All you would have to do is add the exponents. So let's try it with this one. Well, think about it. If I have 3 to the 4th power and I expand it out, it's 3 times 3 times 3 times 3. Now if I multiply that by 3 to the 6th power, that's 6 3s. So now if I take all of this and write it as a power, count them up. There are 10 3s. That'd be 3 to the 10th power. Again, it worked. I can just simply add the exponents. So let's take a look at this one. Multiplying powers with the same base, I should be able to just add the exponents. So I'm going to go right on ahead and do that. But then the base stays the same. 8 plus negative 10 is negative 2. Now of course I wouldn't leave my answer like this because I can't have a negative exponent. Write it as a fraction, bring it downstairs, the base stays the same, but the exponent becomes positive. Now I can simplify. 1 over 6 times 6 is 36. So this expression right here would simplify to 1 over 36. So let's take a look at the top here. What do? To multiply powers with the same base, we add the exponents. Very good. All right, let's try some examples together. I'm going to give you an expression like this. I want you to simplify it using the exponent rules, and then we'll determine which answer choice is best. If you take a look at the expression, every number and letter is stuck together with an invisible operation of multiplication. If it helps you, in this first one, I'm just going to rewrite this, and in between every single term, I'm just going to write a dot to show that we're multiplying. You see? It's all multiplication. Now we know that the order in which we multiply numbers does not matter. So I really could change the order and even put the negative 2 up here by the negative 7. You can see here that negative 7 and negative 2 can be multiplied together. And we know that that's 14. So right now I know my answer can't be B. Now let's take a look at the variables. We have x to the 4th power times x to the 3rd power. Remember, this is x times x times x times x times x times x times x. How many are there? Well, of course, 7. Remember, you can just add the exponents. So this would be x to the 7th power. Now let's take a look at what we have left. We have y's. This is y to the 2nd power, and this y doesn't have a power. We assume it's 1 because there's one y. So y to the 2nd power times y to the 1st power. Again, add the exponents. That would be y to the 3rd power. This would be my final expression in simplified form. And we can see here that that matches up with answer C. So answer C. Okay, number 2. You see on number 2 we have 4 being multiplied by z to the 5th times 9 times z to the negative 12th. Again, remember, you can separate these, spread them out a little bit, especially when we're first learning this. And remember that multiplication, the order doesn't matter. I could reorder this and put the 4 and the 9 first, and then I could put the z's after that. You can see here how the 4 times 9 can be multiplied together. I could have just multiplied 4 times 9 up here, and we know that that's 36. Now I've got the z's. Z to the 5th times z to the negative 12th. I'm multiplying powers that have the same base. Therefore, I can just add the exponents. 5 plus negative 12 is negative 7. Now we know we can't leave our answer like this. Because I have a negative exponent, I want to make a fraction. This negative exponent is going to move downstairs. 36 will stay on top, but z comes downstairs. By moving it downstairs, the exponent becomes positive, and then this is my final simplified form. Go ahead and take a look at the answer choices. You see it matches up with B. Let's try 3. This time we're asked for the area of the square. We know that the area of a square is the length times the width. And being that this is a square, if this is 3z to the 4th, well then this side would also be 3z to the 4th. To find the area, I would want to multiply the length times the width. So I want to multiply 3z to the 4th times 3z to the 4th. Go ahead and try that. Take a look at the answer choices. What do you think the answer would be? I could write it out. 3z to the 4th times 3z to the 4th. Let's see if you were right. Well, we know that 3 times 3 is 9. So right now it can't be C or D. Now we have z to the 4th times z to the 4th. Remember, when you're multiplying powers with the same base, you want to add the exponents. So 4 plus 4 would be 8. Z to the 8ths. Be careful with that one. Sometimes kids want to multiply those together, but you're actually adding. All right. And we have the answer of B. Number 4. This one asks us for the volume. Do you remember back, I think it was probably 6th grade, when you learned how to find the volume of a rectangular prism? Recall, volume is length times width times height. And here we're given the length, we're given the width, and we are given the height, the 3 dimensions of this rectangular prism. So to find the volume, I would want to multiply all 3 of these dimensions together. Go ahead and try it. Feel free to pause the video. Now you might be able to do it just by taking a look at these 3 and saying, well, I'd have to multiply the 2 times 5 times 3 first. And you could do that, and you know that 2 times 5 is 10, and times 3 is 30. So it can't be D. But now you have the exponents. If you feel more comfortable, you could always rewrite this. I could rewrite this as 2x to the y 4th, and then multiply that by 5. x4, I'm doing this side right now. I could write it out first if that's helpful. I wouldn't have to. See, I already multiplied the 2, the 5, and the 3 together. Now I have the exponents. X, x, and x. Remember, this is to the first power. When I'm multiplying powers that have the same base, I want to add the exponents. 1 plus 4 plus 3. That's 8. So we know that we had 30, but now we're going to have x to the 8th. I think I know what the answer choice is at this point, but I'll just go a little bit further here. Let's do the y's. Remember, this is y to the first. So again, multiplying powers with the same base, I want to add the exponents. 4 plus 4 plus 1. Well, that's 9. And I can see here that the volume is going to be this expression. And that matches up with C. Well, the answer would be C. All right, number 5. Take a look at this big, long expression. We're going to simplify it using the exponent rules. Now everything is being multiplied together, even the 4 and the x. It's an invisible operation, but it's still multiply. Probably want to multiply the coefficients first. This -4, the 2, and the 5. Those are all numbers in which can be multiplied together. Well, 5 times 2 is 10, and times -4 would be -40. So I have that part done. Now let's take a look at the variables. I'm going to do them in alphabetical order. X to the 3rd times x to the -8th. When I'm multiplying powers with the same base, I want to add the exponents. 3 plus -8. Okay, let's try the y's. Okay? Multiplying these two, I'm just going to add the exponents. Negative 2 and 5. And then this is what I have. But you notice here that I can't have a negative exponent. So I'm going to write this as a fraction, and x to the negative fifth is going to have to come downstairs. So let's simplify. Negative 40 and y to the third get to stay up top, but x is coming downstairs. The base will stay the same, the x, but the 5 will become positive. And now I have this expression in simplest form. Well, welcome to my world. You guys get to hear my puppies barking at the very scary dog that just walked past the house. Okay, so again, that was the simplified form of number 5. Okay, here's number 6. If you take a look at number 6, you'll see that everything again is being multiplied together. So I could rewrite this with dots in between everything, but you really don't need to. Hopefully you're feeling comfortable with this at this point. Well, let's take a look at the numbers, the coefficient. So I've got 12, and you see this 2 over here? Yep, we got that one too. But what about this negative? There's a negative in front of the m, but there isn't a number there. Would we just assume that that's negative 1? You're right. So this really is negative 1. So that's also a number. We have to pull that one out as well. So I have 12 times 2 is 24, and then multiply that by negative 1, and you're right, that gives us negative 24. Okay, so let's grab all the variables now. We'll do m. Here's an m. There's another one. There's another one. Now you got to pay attention to the exponents. This is an m to the first, another m to the first. Think about this as m times m times m times m times m. Would that be 5 of them? 1 plus 3 plus 1 is 5. So m to the 5th power. You add the exponents. Let's grab the n. Here's n to the first power, n to the negative second. So I want to add the exponents. 1 plus negative 2 is negative 1. Now we know that that's a negative exponent. We're going to have to move it downstairs. We'll do that later. Now what have we missed? This one right here. P to the 5th. Let's pull that one down. Okay, looking at what we have here is an expression that's not quite simplified because of this negative exponent. So I'm going to write it as a fraction so I can see that this is upstairs, and now we're going to move it down. So let's simplify. Up in the top, and then the n, that's moving down here to become a positive 1 exponent, but we know that we don't need to write that. So here we have our simplified form. We started with this expression, and we end up with this one. Not so bad. Last example. Here we're asked to evaluate this expression when c is negative 1 and d is negative 2. Well, remember, before we evaluate, we're going to want to simplify. So let's take a look at our expression. Everything's being multiplied together. Let's multiply the coefficients first. The negative 2 times 5. Well, we can see here that that's just negative 10. So then let's do the c's. I have c to the 4th and c to the 2nd. I want to add the exponents. Negative 4 plus 2. Okay, then I have the d's. Multiplying those powers, they have the same base. Again, I add the exponents. Negative 1 plus negative 3. That's negative 4. Okay, now looking at what I have, I'm going to make a fraction by writing it over 1 because I see that both the c and the d are going to have to move downstairs. That way we can make them positive exponents. So I have negative 10 upstairs. C and d will move downstairs. The negative 2 and negative 4 exponents will become positive. Okay, now I think I'm ready to evaluate. So negative 10 stays in the numerator. C, I'll make parentheses for C, and some parentheses for D. Now I'm just going to take C as negative 1 and plug it right in here for C. And D is negative 2. We'll plug that right in here for D. Feel free to pause the video and work this one out. Let's see what we get. Down here we're multiplying these two together. Negative 1 to the 2nd power is negative 1 times negative 1. That's just 1. And negative 2 to the 4th power, negative 2 times negative 2 times negative 2 times negative 2. I think that's 16. So down here in the denominator, I have 1 times 16, which is 16. Now we can simplify, because you know that a 10 and 16 are both divisible by 2. So it looks like our final answer is going to be negative 5 over 8. Kind of have a little bit of room there to squeeze that in. Negative 5 over 8. There we go. So we took this expression. First, we simplified it. We got this. Then we took the values for C and D and plugged them in. And then we simplified it to get negative 5/8. All right, there you have it. Lesson 7-3. Have a great day.